After Terzagh's theory and Meyerhof theory of ultimate bearing capacity, many researchers tried to develop the ultimate bearing capacity equation. One of these trials was by Bala and 62. Bala proposed a bearing capacity theory based on the failure surface as shown in this figure. One of his theory assumptions was that the arc between point C and point D is an arc of a circle, not an arc of log spiral as assumed by Terzaghi. According to these assumptions, he developed his bearing capacity equation. The bearing capacity equation's solution, bearing capacity solution was obtained using Cotter's equation. Cotter's equation to determine the distribution of normal and tangential stresses on the slip surface. He obtained the following equation. It is similar to the equation developed by Terzaghi, but the bearing capacity factor NC, which is related to cohesion, and NQ and N gamma are or can be determined in a different procedure. The procedure that can be depended on to compute the bearing capacity factor is as follows. First, obtain the magnitude of cohesion divided by B, the width of the foundation, and gamma, the unit weight of the soil, and dF, the depth of the foundation over the width of the foundation. First, obtain these two terms. Then use figure 15 to obtain the magnitude of rho. This figure 15, variation of rho with angle of internal friction as referred by DAS in 2010. Here, four graphs. The first was for dF over B, depth of foundation equal to 0 when the foundation is placed on the surface, ground surface, and dF over B equal to 0.5. The third case, dF over B equal to 1 and dF over B equal to 1.5. The relation between angle of internal friction and rho is presented for different values of cohesion divided by gamma B. C over gamma B from 0 to 2.5 and infinity. Based on the value of phi, for example, if the phi equal to 30 and dF over B equal to 1, and for the curve of C over gamma B equal to 1, we can get the value of rho. According to the value of rho, you can obtain the bearing capacity factor NC and NQ and N gamma by using these figures. The first figure, according to phi from 20 to 40, according to phi, and for different lines of rho equal to 3, 4, and 6. For example, if phi equal to 30 and rho equal to 4, then intersect with the y-axis, you can get the value of NC. In similar manner, you can get NQ from this figure and N gamma from this figure. Another trial is by Hu in 64. In his theory, who assumed that alpha is not equal to phi, is not equal to angle of internal friction like the assumption of Terzaghi. He assumed that alpha depends on gamma and phi and q, and its value is between angle of internal friction and 45 plus pi over 2. According to that, alpha maximum equal to 45 plus pi over 2 and alpha minimum equal to phi. Alpha is between alpha minimum and alpha maximum. According to this assumption, he developed his equation based on the same procedure used by Terzaghi. There are also many trials to develop the ultimate bearing capacity and continue to develop it by Vizek and Hansel.